In topic four, we're going to really look at two things. We're going to look at finding the equation of an ellipse given particular information. And then we're also going to look at something called eccentricity, okay? So just a quick kind of recap of what can the equations of an ellipse look like. If you're centered at the origin, you can have basically two types of equations. We can have x squared over a squared plus y squared over b squared equals 1. Or we can have x squared over b squared plus y squared over a squared equals 1. Why the difference? Well, it's actually really important. A has to be the longest value. So a squared is going to be the bigger denominator. B is going to be the smallest value. So b squared is the smaller denominator. And the larger denominator, whatever variable it's attached to, is going to kind of indicate how this ellipse is oriented. So if the larger denominator, a squared, is attached to x, we're going to have a horizontally oriented ellipse. Okay, so we would have a minor or a major axis that is horizontal. We would have a minor axis that is vertical. If the larger denominator, a squared, is attached to the y, we're going to have a vertically oriented ellipse. So that means the major axis is going to be vertical and the minor axis is going to be horizontal. Okay, so that really does matter. And then we can also have an ellipse that is centered at some other point, hk. And again, we can get two versions of the equation. We can have x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. Or we can have x minus h quantity squared over b squared and then y minus k quantity squared over a squared equals 1. Again, why the subtle difference? It all depends on A. A is the longest side. Okay, it's the distance from the center. It's not the longest side. We can create basically this Pythagorean relationship. And so A is the longest side. It's the hypotenuse of this like right triangle that we can form. But it's going to be the longer length when we're talking about A and B. Okay. So A squared is going to be the bigger denominator. B squared is going to be the smaller denominator. And whichever variable is attached to the bigger denominator tells us how this ellipse is going to be oriented. So if the larger denominator is attached to X, we have a horizontally oriented ellipse, which means it has a horizontal major axis. If the larger denominator is attached to the y, we have a vertically oriented ellipse, and it's going to have a major axis that is vertical. So that really is super important. Okay, so kind of remember that. Now, we're going to first kind of just dip our toe into eccentricity. We don't go deep into it at all in this course. It does come up later for us in 11. I think it's 11.6. We're going to talk about polar form of conic sections. So we're going to kind of get those polar equations and we need eccentricity then. We don't go deep into that section at all. It's something that you touch a bit when you get into Calc 2. So you're not going to see it for a while, but we're just going to kind of scratch the surface of that. So we do need to understand eccentricity for when we get to that, which is going to follow you, later in your math career, depending on what courses you're taking. So we know that we love a definition at the beginning of a video. So we have the eccentricity, which is denoted by a lowercase e. The eccentricity of an ellipse describes how much an ellipse deviates from a circle. Okay, so this is so not formal, but basically, how squished is the ellipse? All right. So we can have like a super squished ellipse, or we can have like a kind of squished ellipse. And the eccentricity, those are both terrible. They look like potatoes. And that's besides the point though. But basically the eccentricity says, okay, how close to a circle is this ellipse? Okay. So you can see this long skinny one. It's further away from a circle than this kind of chubbier one. Okay. So think like the rounder the ellipse is, the closer to a circle it is. The flatter and longer the ellipse is, the further away from a circle it is, okay? So it's just a number, so it's like a constant value, it's just a number. And it again, it tells us like how oval is this shape? How squished is this is this shape compared to a circle? All right. Now it's going to be a number between 0 and 1, and you're going to find out in just a bit why. We're looking at a ratio. Okay. So we're looking at a ratio of two very important things. So we're looking at the ratio of the distance from the center to a focus, that is our C value. And we're going to compare that to the length of what is called the semi-major axis, which is denoted by A. So semi-major axis, what in the world? The major axis goes all the way through the ellipse, through the center and foci. Okay, so it's basically the distance from major vertex 1 to major vertex 2. So if you ever see them talk about the semi anything, they mean half of that. So if we're talking about the semi major axis, what we're really talking about is just a secret way. It's kind of like a really fancy schmancy hoity-toity way of saying, hey, we're looking for the distance from the center to one of the major vertex values. Okay, so this is really the distance from center to major vertex. Okay, we know that to be the value A. Okay, we also know that that's the longest value, and we're talking about A, B, and C. A is the distance from the center to a major vertex. B is the distance from the center to a minor vertex or a co-vertex, and then C is the distance from the center to a focus point. So that distance from the center to one of the major vertex is always going to be the longest. And so if we're looking at a ratio of those two things, we're looking at C divided by A. So some value divided by some bigger value, it's always going to be a value between 0 and 1. So how do we interpret those values? Well, the closer to 0 that the eccentricity value is, the rounder your ellipse is. Okay. The closer to 1, the kind of flatter, longer, more stretched out your ellipse is. Okay. And again, the formula, well, I don't think again, I think this is the first time you've seen it, but the formula officially is C divided by A. Okay. Now, from the equation, we can get A and B really easily. A squared is going to be one of the denominators. B squared is going to be the other denominator. Take the square root of those two and you get A and B. Okay. C, we have to use a Pythagorean relationship. Okay. And so the Pythagorean relationship that we must remember is A squared equals B squared plus C squared. And this visual right here kind of explains why that is, okay? You can see A, B, and C. A, they have kind of, they've secretly given you the A value kind of in a different way. But we can see here, let's do different colors. So we can see from the center, whoops, from the center to either focus, that's going to be a length of C, okay? And then we can say from the center to a co-vertex, that's going to be B, okay? Now, what you really need to understand is from the center to a major vertex is A. But it just so happens this like navy blue distance that I've drawn here is the same as this distance here, okay? And if you need to pull out your string and you need to cut it and measure it, I promise you they're the same thing. So this distance along what we've created, this like right triangle that we've created, A, it's the same thing as the distance from the center to the major vertex. They're the same thing, okay? So because A is the longest of those three values, A ends up being the hypotenuse of that right triangle that we can form from the center to a co-vertex and then the center to a focus point, okay? So again, A squared equals B squared plus C squared. This is not the traditional Pythagorean theorem that we remember before. You have to be very cautious of what is A and what is B and what is C, okay? Now, with all of that said, let's look at an example. So when you're finding the equations, it's not the hardest thing you're ever going to do, but they can get a little bit messy. They can be a lot of work. You've already seen that with the previous examples that we've looked at. There's just lots of little bits and pieces. None of the little bits and pieces are that hard. There's just a bunch of them. So be very neat, be very organized. Try not to write so giant. Try to be very, very like, use good penmanship when you do this stuff here, okay? So for example 3, it says find the equation in standard form. So standard form being what I wrote up here at the top of the page. Okay, those are the standard form for whether you're centered at the origin or some value hk or some order pair hk. So we want a standard form equation for an ellipse that is described below, and then we're told, hey, while you're at it, go ahead and find the eccentricity. So let's figure out how squished this ellipse is, okay? Now, we are told that we have foci at 0, 3, and at 0, -3, and we have a major axis length of 10. So what I would do is I would start with kind of like a little sketch because we need to figure out, are we vertically oriented or horizontally oriented? And the foci tell us because the foci have to be on the major axis, okay? So let's kind of start with a little sketch. So I'm going to draw an XY plane. All right, so we have foci or focus points at 0, 3. So how do I get to the point 0, 3? Well, at the origin, I don't go left or right, but I do go up. So this is the first focus point, and then this is the second focus point. So what this tells me is this is definitely vertically oriented. Okay. Now, we know a couple of things here. We know without a shadow of a doubt that the major axis, okay, it has a length of 2a, okay? So from the center to the first vertex is a length of a, and then from the center to the other vertex is a length of a. So the distance along the major axis is 2a. So the major axis equals 2a. But then we're also told that the major axis has a length of 10. So we're also told, hey, by the way, the major axis is also 10. Okay, so we're told these things. Well, I did not mean to do that. Can I undo what I just did? Yes, I can. All right, so we can use that to figure out what A is. A is the distance from the origin, or from the center, we'll say, to a major or minor vertex. Now, question is, where are we centered here? I probably should have started with that. Where is the center here? Since the foci points, the focus points, since the focus points are on the y-axis, that tells me that I'm going to end up being centered right here. Okay, so we can go ahead and just say, hey, we're going to be centered along the origin or at the origin. All right. So we know that the major axis is 2a. We know that the major axis is also 10. So we can say, hey, well, 2a has to equal 10. If I divide both sides by 2, I get that a is equal to 5. So 5 is going to be the distance from the center to the first vertex, and then the distance from the center to the second vertex. So at the origin, I want to go up 5, and then I want to go down. That is pitiful. Let me draw this again. So foci 1, well, it'd be focus 1, focus 2, and then vertex 1, vertex 2. So notice from here to here, I have a distance of 10. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, and bam, 10. So the two vertex points, the two vertices, they are 10 units apart. Okay? So that's all well and good. What we know now is we know C, okay? From the center to a focus point is C. So C is equal to what? Well, here's my center, and to get to the first focus point, I go 1, 2, 3. To get to the second focus point, I go 1, 2, 3. So C is equal to 3. A, we already know what A is. We found it algebraically. We said, hey, A is 5. So knowing that, I can go ahead and figure out what B is. Okay, so remember, we have a situation like this. This is A, this is B, this is C. Okay, we can use that Pythagorean identity to figure out what B has to be. Remember, it is A squared equals B squared plus C squared. So let's plug in what we know. We know that A is 5. We don't have a clue what B is. We know that C, whoops, that's a plus sign. We know that C is 3. So let's see, we get 25 equals B squared plus 9. I want to get B squared alone, so I would subtract 9 from both sides. So that tells me that b squared is equal to 16. Okay, so then if I take the square root of both sides, I get that b is equal to 4. So remember, b is the distance from the center to the co-vertices. So that's going to be along your minor axis. So this is our major axis. This is our minor axis. So I can go 1, 2, 3, 4, 1, 2, 3, 4. All right, so we've got a little sketch here, but most importantly, we need to get an equation. And in order to get the equation, we need to understand our center. Our center is at the origin. So we know we're going to have an x squared plus a y squared equals a 1. But we have to figure out where a and b go. So we know a squared and b squared are going to be the denominators, okay? But which one goes with which, all right? You have to remember that the larger denominator is going to go with whichever variable depending on its orientation, okay? So if you have a vertically oriented ellipse, that tells you that the a value, the a squared, is going to go with your y, and the b is going to go with your x, okay? So we want to take b squared, and we want to take a squared, okay? So we're going to get x squared over 3 squared. Nope, 4 squared, 4 squared. Don't put a 3, put a 4. Please put a 4. And then we're going to get y squared over a squared, which is 5 squared. So we end up with x squared over 16 plus y squared over 25 equals 1. And that's all she wrote. And that makes sense because along the x-axis, we're going to go a distance of 4 units from the center. Along the y-axis, we're going to go a distance of 5 units from the center. That's going to give us the basic shape of our parabola. We already knew those foci points. Let's do them in green. Those are here and here. We were given those, okay? So now all that we have to do is find the eccentricity, and it's really, really easy, especially if you have your values for A, B, and C. You just need really A and C. So eccentricity, I have heard somebody pronounce it eccentricity. I've never heard it pronounced that except the one time, but I really don't care what you call it. You can call it whatever you want, as long as you know how to calculate it on a test. So the eccentricity, remember, it's denoted by E, and it's the ratio of the distance from the center to a focus point, so C, compared to the distance from the center to one of the major vertex points, so A. Well, C we knew was 3, A we know is 5, so there you have it. Our eccentricity is 3/5, okay? So that just gives us a number, and if you have lots of different ellipses, okay, and you compare the eccentricity of each of those, any value that is closer to 0, so it's like the closer to 0, the rounder the ellipse, the closer to 1, the more like spread out the ellipse, okay? So there you have it. That is finding the equation of an ellipse. Do understand that this one is certainly centered at the origin because our foci points, the focus points is what I should really say. The focus points are along the y-axis. That says, hey, we're going to be oriented where the center is going to be at the origin. All right, one more example. And the next one, I will tell you, it is a doozy. So kind of like brace yourself, really put on your algebra brain, okay, because you're going to need it here. All right, so for example 4, it says, show that the following is an ellipse. Graph the equation and then state the vertices, the foci, and the eccentricity, okay? So we got a lot going on here. And looking at this gigantic mess of an equation, you're like, ellipse, what, where, how? Well, it is, and we're going to figure out how to prove it, okay? Now, in a future section, I want to say it's 11, it's definitely 11.5. We're going to talk about kind of like a general form of a conic section and how we can easily, like very easily determine, is it a circle, is it a parabola, is it an ellipse, or is it a hyperbola? But at this point, we don't have that skill set yet, so we have to kind of do this by like just sheer will and brute force, okay? So I will tell you that we're definitely not going to be centered at the origin for this one. So when we go back to those like standard equations, I'm going to actually scroll back to the typed out versions. We're going to be dealing with equations that are going to be of some format like this, okay? And notice we have like an x minus some value squared, and then we have like a y minus some value squared. And anytime you see that, it kind of screams circle, okay? So we know that if we have x minus h squared plus y minus k squared equals r squared, that we have a circle, okay? And one thing that you have to remember about circles is when you have the general form of the equation of a circle and you need to go to standard form, this being standard form right here, general form being like it multiplied out, you have to do everybody's favorite, which is completing the square. So when you see this x minus h squared, y minus k squared, that's very like, this is not a circle because of those denominators, but we feel very circular, okay? And when you were back in 171, in that chapter on circles, you would have general form of a circle, which was basically that circle multiplied out, and you had to put it back in standard form. That's kind of similar to what we're doing here. We want to morph this into some format. Our goal is to get something where we have x minus h squared over a or b squared plus y minus k squared over whatever variable the opposite one squared equals 1. We're nowhere near that. Okay, so let's kind of set the stage for completing the square. Let's group our x terms, let's group our y terms, and leave plenty of space to like do the actual completing the square. So we've got 4x squared minus 32x. I'm going to kind of group those. And then I've got y squared plus 16y. I'm going to leave a little space. And then you always want to take whatever the constant is and scoot it to the other side. So we're going to subtract 124 and leave it on the other side. Okay? Now, one thing that you have to remember about completing the square is before you can complete the square, the coefficient on the squared term must be 1. Okay? So when we're looking at this x situation, we don't have a coefficient of 1 on the square term. So we're going to have to do a little more work there. So let's hold off on that one for just a second. Let's focus on the y. Okay. Now remember, to complete the square, we add b over 2 quantity squared to both sides. Okay. Well, for C, when we're talking about B, okay, for C, for the Y's, when we're talking about B, we're talking about the coefficient of the linear term. So we're not talking about the coefficient on the square term. We're not talking about the constant. We're talking about the coefficient on just plain X or just plain Y. So right here, if we kind of mosey up, we can say, okay, well, 16 is B. We want to divide it by 2, and then we want to square it. Well, that's 8 squared, which would be 64. So I want to add 64, and I'm going to do this on both sides of the equation. I'm going to just give myself a little more room here. Now, it's the X stuff that we have to be so careful with. So what we're going to do first is we're going to factor kind of like a 4 out, okay? So we're going to divide 4x squared by 4. That's just going to leave us with an x squared. We're going to divide negative 32x by 4, which is going to leave us with negative 8x. And we're going to have a 4 out front. The issue is when we complete the square, we have to remember that technically we're completing the square and then we have to multiply by like this 4. We have to sort of think of like, oh, well, really, I'm distributing this 4 through. So we've got to be really careful when we add to both sides, okay? So let's think about this one here. We've got b is negative 8. We want to divide it by 2 and then square it. So we get negative 4 squared, which is 16. So we would add 16. But the issue here is, what do I add on the right-hand side of the equation? I don't want to add just 16 because technically I need to distribute this 4, which means that technically what I've done is I've really added 4 times 16 on the left, which means I have to add 4 times 16 on the right. And 4 times 16 is just 64. All right, so again, you got to keep in mind when we distribute this 4, we're really distributing the 4 through the x squared, the negative 8x, and the 16. So even though inside parentheses, when we completed the square, we just added a 16 to compensate for what's really happening on the left, we have to add 4 times 16 on the right, okay? Now, we've completed the square. We're in great shape to do the factoring. So for the x's, we're going to have that 4 outside parentheses, and then we want to take x, which is the square root of x squared. We want to take 4, which is the square root of 16. We're going to subtract them and then square that quantity. And then the square root of y squared is y. The square root of 64 is 8. We want to add those and then square the quantity. And the reason we're adding, I'm going to kind of highlight, we're adding and subtracting because of what's highlighted here. Okay. Now, negative 124 and then plus 64 plus 64. So let's see, 64 plus 64 is 128. So negative 124 plus 128 is 4. Okay. So we're getting there. We're getting somewhere anyway. So we're not quite to that standard form yet. We don't have a 1 right here, and we need a 1. So in order to get that 1, we would divide everything by 4. So that's going to ultimately simplify to be x minus 4 squared just over 1 plus y, don't put a square right here. Inside those parentheses, make sure it's just plain y plus 8, not y squared. I had a squared when I didn't need one. So we get y plus 8 squared over, well, there's technically a 1 here. 1 divided by 4 is just 4. And then that all equals 1. So finally, it took a lot of work, but we do have something that is very much an ellipse. So it's an ellipse. Y'all. So that was kind of our goal. Hey, show that this is an ellipse. We had to do a lot of fancy work. We had to do some algebra, this completing the square on 2 different parts here. We had the really weird situation where we had this like coefficient of 4 on the x squared, and we had to play around with that. But at the end of the day, look at what we have here. So we have an ellipse. Let's go ahead and figure out the center. So remember, the center is always going to be of the form HK, where H is what was subtracted from X. So H is 4. And then K is what is subtracted from Y. So if we have Y plus 8, what we would have really subtracted was we would take Y minus negative 8. So we get 4, negative 8. That's our center. Okay. Now, if that's our center, that's all well and good. We can go ahead and plot that. So 4, negative 8 is going to be way down there, okay? We need to figure out our major and our minor axis. So the major and minor axis are certainly going to go through the center, but is this vertically oriented or is this horizontally oriented? And it's all about where was the bigger denominator, okay? So which one had the b squared, which one has the a squared? Since the larger denominator is with the y, this is going to be vertically oriented. Okay? And what that tells me is that my major axis, if this is vertically oriented, my major axis is going to be a vertical line through the center. So my major axis is going to be x equals 4. Let me change this to an arrow so I don't get weird marks here. All right, and then my minor axis is always going to run perpendicular to the major axis. Since my major axis is vertical, my minor axis is horizontal, and it's also going to go through the center, so it's going to be y equals negative 8. So we got a lot of information already, okay? We've got our center, and we know our major and our minor axis, okay? So let's go ahead and label those. So the major axis is vertical. There we go. So this is the major axis. The minor axis is horizontal. So this one is minor. And we have our center. So what we need to find now would be the vertices, okay? Now we have major vertices. Those are like, we just generally call them just the vertices. And then we have minor vertices. So let's talk about major vertices first. So the major vertices have to run along the major axis, okay? So what's going to end up happening is that x value is not going to change, but the y value is. From the center, we need to go up and we need to go down. So the vertices are going to be h, comma, k plus or minus a, okay? And then the minor vertices or the co-vertices, they're going to be along the minor axis. So the y coordinate is going to stay. We're going to have to change the x values. So we're going to get h plus or minus b, comma, k. And then we also have to find the foci. Now, the foci run along the major axis. From the center, they're C units up or down in this case. They're going to be C units away from the center. So the center is at HK. We don't need to change the H value, the X coordinate. We do need to change the K value, the Y coordinate. So these are going to be at H, comma, K plus or minus C. So we need to find some values. We need to figure out what A, B, and C are. Okay? Well, A squared is always the biggest denominator. So A squared is 4, which tells me that A is the square root of 4. So it's going to be plus or minus 2. B is always, or B squared is always the smaller denominator. So B squared is 1, which tells me that B is the square root of 1, or just 1. And then C, we have to do some work. Okay, so remember, A squared equals B squared plus C squared. So C equals, if we do a little fancy footwork, which we've done it in previous videos if you need to go back, it is going to be A squared minus B squared. Let me scroll down just a tiny smidgen more. I know this video is running long, but I don't want to rush any of this, okay? So we know that A squared is 4. We know that B squared is 1. So C is going to be the square root of 3, or the square root of 3, I don't remember it. It is, whoops, the square root of 3 is 1.7-ish. Okay, so we have now, let's draw. We have values for A, B, and C. So let's go ahead and find the vertices and the foci. Okay, so for H, for the vertices, the major vertices, H stays the same, so that's going to be 4. And then the Y coordinate, that -8, it's going to be changed. So it's going to be -8 plus or minus A, which is 2. So that's going to give me 4, comma, -10 and 4, comma, -6. So 4, comma, -6, 4, comma, -10. This is a teeny tiny little ellipse. Okay. Now for the co-vertices, those are going to be the ones along the minor axis. H is going to change. So we want the 4. We're going to add and subtract B from that. So we're going to go 4 plus or minus 1, comma, K is going to stay the same. So it's going to be -8. Excuse me. So we have co-vertices of 3, -8, and 5, -8. So let me highlight those so we don't get lost with all of our super important points here. All right, and then the foci, the H value from the center is going to stay. So it's going to have an X coordinate of 4. And then the K value from the center, that's going to be the Y coordinate of the center. It is going to change. We're going to change it by a value of C. So we get -8 plus or minus 1.7. So we're going to get focus points of 4, comma, -9.7. And 4, comma, let's see, what's that? 6, -6.3. Is that right? I think I'm good there. Did I get them right? -6.3, -9.7. We're good. Okay, so we've got our focus points here and here. So let's finish plotting. This is going to be really scrunched because this is such a teeny tiny little ellipse. Let's see. So we've got our main vertices. Our minor vertices are at 3, -8, and 5, -8. So they're going to be right there. So we can go ahead and draw this. And then the focus points, they're going to be a little hard to put in here. So we've got 4 almost at 10, and then 4 just barely past -6. So that's going to be F1 and F2. So there you have it. This was a very long problem. Okay, I'm exhausted. I'm assuming you're exhausted. Hopefully this is making a lot of sense to you. It's not that any of the steps are hard. None of these steps are terribly difficult. There's just a lot of little tiny pieces. So really understand this process, find the center, determine how you're oriented. How you're oriented will tell you what your major and minor axis is, or axes are going to be. Find your vertices, find your foci. Remember, to find the foci, you have to find C. And in order to find C, you have to have a strong understanding of what that Pythagorean identity is. You must know that, okay? So there you have it. We've got one more example left. So one more really quick video, and then we're done with this section.